And now in this lecture we'll answer on two questions. The first question, we find out the length of this tangent MF that is equal to x. And in the second question, we find out the length of this tangent AP that is also equals to x. So we start with the first question. In the drawing we have three identical circles, and this is the tangent ABC that is tangent to this circle at point A, it is tangent to this middle circle at point B, and it is tangent to this circle at point C. In addition, we know that line segment AB equals to 3 units in its length, and line segment BC also equals to 3 units. And we also have, this is the common extreme point M. From this common extreme point M, we have tangent MD. Tangent MD is tangent to this circle at this point D. The length of this tangent MD is equal to 5 units. In addition, we also have tangent ME that is tangent to this circle at point E. The length of tangent ME is 7 units. And finally, we have tangent MF that is tangent to this circle at point F. The length of tangent MF is x, and our mission is to find out the length of this tangent MF that is equal to x. We have to find out the value of x. So first of all, we define the center of this circle, this point P. We define the center of this middle circle, this point is point Q. And finally, we define the center of this circle, this point is point S. And we join points P and D together by a straight line. Point D is the point of tendency of tangent MD with this circle. So what is the definition of line segment PD? Line segment PD starts from point P, that is the center of this circle, and ends at point D, that is a point of the circle itself. So this is exactly the definition of a radius. Therefore PD is the radius of this circle. We define the radius of this circle as R, so PD equals to R. And because of the fact that those circles are identical circles, the radii of those two circles must be also equal to R. So here we have the radius PD is drawn to point D, that is the point of tendency of tangent MD with this circle. And whenever you have a radius that is drawn to the point of tendency, then tangent MD will be perpendicular to the radius DP. If MD is perpendicular to DP, it means that this angle equals to 90 degrees according to rule 1. In the next step, we join points M and P together by a straight line. By joining points M and P, we created the right triangle, triangle MPD. So we implement the Pythagoras theorem on this right triangle, triangle MPD. According to the Pythagoras theorem, in any right triangle, the square of the hypotenuse equals to the sum of the squares of the perpendiculars. The hypotenuse in this right triangle MPD is MP. Therefore, the square of the hypotenuse is MP squared, and MP squared equals to PD squared plus DM squared. So I'll write it down. So MP squared, that is the square of the hypotenuse, is equal to PD squared plus MD squared. Repeat again, according to the Pythagoras theorem in this right triangle MPD, MP squared equals to PD squared plus MD squared. MP is the missing side, so we leave it as it is. So it is MP squared equals to PD squared. PD is R, therefore PD squared is R squared plus md square. Md is 5, therefore md square equals to 5 squared, that is 25. So in total, actually, according to equation 1, we found out that mp square equals to r square plus 25. We repeat on the sum process on this middle triangle, on this middle circle. That is to say, we will join points Q and E together by a straight line. QE is of course the radius of this circle that is equals to R, and because of the fact that the radius QE that is equal to R, the radius QE is drawn to point E, that is the point of tendency of tangent ME with this circle, and whenever you have a radius that is drawn to the point of tendency, then tangent ME will be perpendicular to the radius EQ. If ME is perpendicular to EQ, it means that this angle equals to 90 degrees according to rule 1. In the next step, we join points M and Q together by a straight line. By joining points M and Q, we created the right triangle, triangle MQE. So we will implement the Pythagoras theorem on this right triangle, triangle MQE. According to the Pythagoras theorem, on this right triangle, triangle MQE, MQ squared, that is the square of the hypotenuse, equals to QE squared plus ME squared. Repeat again, according to the Pythagoras theorem, in this right triangle, triangle MQE, MQ squared equals to QE squared plus ME squared. MQ is the missing side, so we leave it as it is. So it is MQ squared equals to QE squared. QE is R, therefore QE squared is R squared plus ME squared. ME is 7, therefore ME squared is 7 squared, that is 49. So in total, according to equation 2, we actually found out that MQ squared equals to R squared plus 49. So we repeat on the sum process on this circle. That is to say, we will join points S and F together by a straight line. SF is of course the radius of this circle that is equals to R, and because of the fact that the radius SF, the radius SF that is equals to R, the radius SF is drawn to point F, that is the point of tendency of tangent MF with this circle. And whenever you have a radius that is drawn to the point of tendency, then tangent MF will be perpendicular to the radius FS. If FF is perpendicular to FS, it means that this angle equals to 90 degrees according to rule 1. In the next step, we will join points M and S together by a straight line. So joining points M and S, we created the right triangle, triangle MSF. So we'll implement the Pythagoras theorem on this right triangle, triangle MSF. According to the Pythagoras theorem, in this right triangle MSF, MS squared, that is the square of the hypotenuse, is equal to SF squared plus MF squared. Repeat again, according to the Pythagoras theorem, in this right triangle MSF, MS squared, that is the square of the hypotenuse, equals to SF squared plus MF squared. MS is the missing side, so we leave it as it is, so it is MS squared equals to SF squared. SF is R, it is the radius of the circle, that is equal to R. So therefore, SF squared is R squared plus MF squared. MF is X, that is the tangent that we are looking for in this question. MF is X, therefore MF squared is X squared. So in total, according to equation 3, we actually found out that MS squared equals to R squared plus X squared. In the next step, we will join points P and A together by straight line. Point P is the center of this circle, point A is the point on the circle itself, therefore PA is the radius of this circle, that is equal to R. And because of the fact that the radius AP is drawn to point P, that is the point of tendency of a tangent AP, and because of the fact that the radius PA is drawn to point A, that is the point of tendency of tangent ABC with this circle, therefore tangent ABC will be perpendicular to the radius AP. If ABC is perpendicular to AP, it means that this angle equals to 90 degrees, and this angle also equals to 90 degrees according to the same rule, rule 1. Likewise, we will join points Q and B together by straight line. QB is of course the radius of this middle circle, that is equal to R. Again, because of the fact that the radius QB, that is equal to R, the radius QB is drawn to point B, that is the point of tendency of tangent ABC with this middle circle. Therefore, tangent ABC will be perpendicular to the radius BQ according to rule 1. If ABC is perpendicular to BQ, it means that this angle equals to 90 degrees, and this angle also equals to 90 degrees according to the same rule, rule 1. And finally, we'll join points S and C together by straight line. CS is of course the radius of this circle, that is equal to R. Again, because of the fact that the radius SC that is equals to R, the radius SC is drawn to point C, that is the point of tendency of tangent ABC with this circle, and whenever you have a radius that is drawn to the point of tendency, then tangent ABC will be perpendicular to the radius SC. If ABC is perpendicular to SC, it means that this angle equals to 90 degrees, and this angle also equals to 90 degrees according to the same rule, rule 1. So we have here the points P, Q, and S. Those 3 points are at the same distance from the straight line ABC. Again, the 3 points P, Q, and S are at the same distance from the straight line ABC, and therefore points P, Q, and S are located on one straight line. That is to say, PQS is one straight line. So PQS is a straight line, and exactly because of the same fact that points P, Q, and S are located at the same distance from the straight line ABC, the distance of those 3 points P, Q, and S from the straight line ABC is exactly R. The distance between points P and the straight line ABC is R, because PA equals to R. Likewise, the distance of point Q from the straight line ABC is QB, that is R. And finally, the distance of point S from the straight line ABC is R. SC equals to R. And therefore, the straight line PQS is parallel to the straight line ABC. Again, because of the fact that the distance of those 3 points P, Q, and S from the straight line ABC is the same distance that is R. Therefore, the straight line PQS is parallel to the straight line ABC. And therefore, we can implement here Rule 17. So repeat quickly on Rule 17. According to Rule 17, the sum of one-sided interior angles between two parallel lines is equal to 180 degrees. So in the drawing, we have line A that is parallel to line B. This is the line C that intersects with those two parallel lines A and B at those 2 points. In addition, we have those two angles, alpha and beta. Those two angles, alpha and beta, are defined as one-sided interior angles. They are one-sided angles because of the fact that they are located at the same side of the straight line C. They are both located on the left side of the straight line C, and therefore they are defined as one-sided angles. Angles alpha and beta are defined as an interior angles because of the fact that those two angles alpha and beta are located between the parallel lines A and B. Okay, and therefore in total they are defined as one-sided interior angles. And according to this rule 17, the sum of two one-sided interior angles is equal to 180 degrees. That is to say, angle alpha plus angle beta, in total they are equal to 180 degrees. The same thing is true here. Angle 2 and 1 are defined also as one-sided interior angles, and therefore angle 2 plus angle 1, in total they are equal to 180 degrees in their sizes. So we can implement Rule 17 in our drawing. In our drawing, we have those two angles that are defined as one-sided interior angles, and because of the fact that those two one-sided interior angles are located between the parallel lines PQS and ABC, the sum of those two angles must be equal to 180 degrees. So this is a right angle, it is equal to 90 degrees according to Rule 1, plus this missing angle. In total, the sum of those two angles must be equal to 180 degrees according to Rule 17. Therefore, this missing angle must be equal to 90 degrees in its size. Likewise, those two angles are also defined as one-sided interior angles. This angle equals to 90 degrees, plus this missing angle. In total, the sum of those two angles must be equal to 180 degrees. Therefore, this missing angle must be equal to 90 degrees in its size according to Rule 17. Those two angles are also defined as one-sided interior angles, and therefore the sum of those two angles they must be equal in total to 180 degrees. This angle equals to 90 degrees, plus this missing angle. In total, the sum of those two angles must be equal to 180 degrees, and therefore this missing angle must be equal to 90 degrees in its size according to Rule 17. And finally, those two angles are also defined as one-sided interior angles. Therefore, according to Rule 17, the sum of those two angles must be equal to 180 degrees. This angle equals to 90 degrees. So 90 degrees plus this missing angle, in total, the sum of those two angles must be equal to 180 degrees. Therefore, this missing angle must be equal to 90 degrees in its size. So inside this quadrilateral PQBA, we have 4 right angles, and according to Rule 5, any quadrilateral that has 4 right angles must be at least right angle if not a square. So we write to this quadrilateral PQBA as right angle because it has 4 right angles. But we also know that the opposite sides of a rectangle are equal to each other. So in rectangle PQBA, side AB must be equal to the opposite side PQ, but AB is 3, therefore PQ must be also equal to 3 units in its length. Likewise, inside this quadrilateral QSCB, we have 4 right angles, and therefore this quadrilateral is a rectangle according to Rule 5. And according to the rule that the opposite sides of a rectangle are equal to each other, we get that in this rectangle QSCB, side BC must be equal to the opposite side QS, but BC is 3, therefore the opposite side QS must be also equal to 3 units in its length. In the next step, I'll copy the big triangle MPS in a new page and analyze this big triangle MPS. So here, this is the big triangle MPS that I copied from the original drawing. Line segment, the red line segment MQ is defined as the median of this triangle MPS. So what is the definition of a median? Median is a line segment in the triangle that connects the vertex to the midpoint of the opposite side. Again, a median of a triangle is a line segment that connects the vertex to the midpoint of the opposite side. So the median MQ connects the vertex M to point Q, that is the midpoint of the opposite side PS. Why point Q is the midpoint of PS? Because of the fact that the opposite side PS in total equals to 3 plus 3, that is 6, and point Q bisects side PS into two halves. The first half is PQ, that is equal to 3 units, and the second half is also QS, that is also equals to 3 units in its length. Okay, so the median MQ bisects the opposite side of this triangle MPS. Side PS is the opposite side in relation to vertex M. Again, the median MQ bisects the opposite side PS, it divides it into two halves. But the question is, what is the length of the median MQ? Actually, we have a special formula for the length of a median in a triangle. This is triangle ABC. Side AB equals to B units in its length. This is side AC, that is equal to C units in its length. This is side BC, that is equal to A units in its length. The median of this triangle ABC is the median AD that bisects the opposite side BC. That is 3 divided into two halves. The first half is BD, the second half is DC, and each half equals to BC over 2. So the median AD bisects the opposite side BC. Okay. But the question is, what is the length of the median AD? The length of the median AD is equal to the square root of 2b squared plus 2c squared minus a squared over 2. Again, the length of the median AD is equal to the square root of 2b squared plus 2c squared minus a squared over 2. So we use this new formula in order to find out what is the length of the median MQ in this triangle MPS. According to the new formula, the length of the median MQ will be equal to the square root of 2 times MP squared plus 2 times ms squared minus ps squared divided by 2. This equation is the implementation of the new formula in our triangle MPS. So mq equals to the square root of 2 times mp squared plus 2 times ms squared minus ps squared over 2. Here we multiply this equation 1 by 2, and we get that according to equation 1, 2 times mq is equal to the square root of 2 times mp squared plus 2 times ms squared minus ps squared. Repeat again. After we multiply this equation 1 by 2, we shall find out that according to equation 1, 2 times mq equals to the square root of 2mp squared plus 2ms squared minus ps squared. Here we'll square both sides of this equation 1. So 2 times mq squared is equal to 2 squared, that is 4 times mq squared. So in total 2 times mq squared is 4mq squared, and it is equal to, we have to square also this side of equation 1. Actually the root and the square are two opposite operations, therefore the square will cancel the root, and we left only with what is inside the root, that is 2mp squared plus 2ms squared minus ps squared. Repeat again. After we squared both sides of this equation 1, we shall find out that 4 times mq squared equals to 2mp squared plus 2ms squared minus ps squared. So in this side of this equation 1, we have 4 times mq squared. But mq squared according to this equation 2 is equal to r squared plus 49. Therefore, we substitute mq squared here by r squared plus 49, and it is equal to 2 times mp squared. But mp squared according to this equation 1 equals to r squared plus 25. Therefore, we substitute mp squared here by r squared plus 25. We have plus 2ms squared. But ms squared according to this equation 3 equals to r squared plus x squared. Therefore, we substitute ms squared here by r squared plus x squared, and we have also minus ps squared. ps in total equals to 3 plus 3, that is 6. Therefore, ps squared is 6 squared, that is 36. Therefore, minus ps squared is minus 36. So here we'll open the brackets on both sides of this equation 1, and we get that 4 times r squared plus 4 times 49 is 196, so it is plus 196 equals to 2 times r squared plus 2 times 25, that is 50, so it is plus 50 plus 2 times r squared plus 2 times x squared minus 36. So here we subtract 400 squared we subtract 4r squared for this equation. So here, this is for equation 1, 4r squared will get cancelled, and we left only if 196. And the other side of this equation 1, we will also have to subtract 4r squared. 2r squared plus 2r squared is 4r squared, so those two expressions also will get cancelled. after cancel those two expressions, we left only with 50 minus 36, that is 14, plus 2x squared. So in total, according to equation 1, we actually found out that 196 equals to 14 plus 2x squared. Here we subtract 14 from this equation, equation 1, and we get that 196 minus 14 is 182, so 182 equals to 2x squared. Here we divide this equation 1 by 2, and finally we get that x squared, according to equation 1, x squared equals to 182 over 2 is 91, so x squared equals to 91. Here we take a root out of this equation, and finally we get that x equals to the square root of 91. The square root of 91 is 9.54 units. And that is the answer to the question. That is to say, I should found out that the length of this tangent MF, it is equal to either the length of tangent MF that is equal to x is equal to either square root of 91 units, or in terms of numbers, the length of tangent MF that is equal to x is equal to 9.54 units. Okay, so we finished with the first question. In the next step, I present to you the second question, and we will solve the second question of this lecture. So in the second question, our mission is to find out the length of this tangent AP is equal to x. Tangent AP is tangent to this small circle, and we have to find out what is the length of AP is equal to x, so what is the value of x. So in the domain we have quarter circle AOB. Inside this quarter circle AOB we have this small circle. The small circle tangent OB is tangent to this small circle at this point Q. In addition, the small circle touches the big quarter circle at this point. This is their touching point. So we define this their touching point. This point is point K. We also know that this is line segment OQ that is equal to 5 units in its length. Again, our mission is to find out the length of tangent AP that is equal to x. We have to find out the value of x. So first of all, we define the center of this circle. This point is point C. And we will join point C and Q together by straight line. What is the definition of line segment CQ? Line segment CQ starts from point C, that is the center of this circle, and then at point Q, that is the point on the circle itself. Therefore, CQ is the radius of this circle. So we define the radius of this whole circle as A. CQ equals to A, according to our definition. And because of the fact that the radius CQ that is equal to A, the radius CQ is drawn to point Q, that is the point of tendency of tangent OB with this small circle. And whenever you have radius that is drawn to the point of tendency, then tangent OB will be perpendicular to the radius QC. If OB is perpendicular to QC, it means that this angle equals to 90 degrees, and this angle also equals to 90 degrees according to rule 1. Likewise, we join points P and C together by straight line. Again, point P is the point of tendency of tangent AP with this small circle. CP is of course the radius of this circle that is equal to A units according to our definition. And because of the fact that the radius CP is drawn to point P, that is the point of tendency of tangent AP with this small circle, whenever you have a radius that is drawn to the point of tendency, then tangent AP will be perpendicular to the radius PC. If AP is perpendicular to PC, it means that this angle equals to 90 degrees according to rule 1. In the next step, we will join points A and C together by a straight line. By joining points A and C, we get the right triangle ACP. In the next step, I copy the right triangle ACP in a new page, and we will implement the Pythagoras theorem on this right triangle ACP. Here by PT is the abbreviation for Pythagoras theorem. So actually, this is the right triangle APC that I call it from the original drawing, according to the Pythagoras theorem. In this right triangle ACP, AC squared, that is the square of the hypotenuse, equals to AP squared plus PC squared. So I write it down. This will be equation 1. AC squared, that is the square of the hypotenuse, is equal to AP squared plus PC squared. The hypotenuse AC is the missing side, so we leave it as it is. So it is AC squared equals to AP squared. AP is x, therefore AP squared is x squared. X is the tangent that we are looking for in this question. Plus PC squared. PC is a, therefore PC squared is a squared. So in total, according to equation 1, we actually found out that AC squared equals to x squared plus a squared. So, as I already mentioned before, point K is the touching point. This is point K, that is the touching point between the small circle and the big quarter circle. They touch each other internally, and this point K. That is to say, we have an internal notch between the small circle and the big quarter circle at point K. And whenever you have an internal notch between two circles, you can implement rule 9. So I'll repeat quickly on rule 9. According to rule 9, if two circles touch each other internally, then the straight line that connects their centers together passes through their touching point. So in the drawing, we have two circles. The center of this big circle is 0 at point O. The center of this small circle is 0 at point M. And the straight line that connects their centers together is, of course, the straight line OM. And according to this rule 9, the straight line OM must pass through their touching point, that is point P. Again, the straight line OM must pass through point P, that is their touching point. Or OMP is one straight line. Again, according to rule 9, OMP is one straight line. So we can actually implement rule 9 in our drawing because we have internal notch between this small circle and this big quarter circle and this point K. According to rule 9, we have the center of this big quarter circle is 0 at point O. The center of this small circle is 0 at point C. And the straight line that connects their centers together is, of course, the straight line OC. And according to rule 9, the straight line OC must pass for the touching point, that is point K. Again, the straight line OC must pass for point K, that is their touching point. Or OCK is one straight line. Again, OCK is one straight line according to rule 9. So we join points O and C together by straight line. And the straight line OC must pass for point K according to rule 9. From the drawing, it is very easy to see that the straight line OC indeed passes for point K, that is the touching point, so it is exactly according to rule 9. But what is the length of line segment CQ? Point C is the center of this small circle, point K is the point of the circle itself. So this is exactly the definition of a radius. Therefore CK is the radius of this small circle, that is equal to A. What is the definition of line segment OK? Line segment OK starts from point O, that is the center of this quarter circle, and ends at point K, that is a point on the quarter circle itself. So this is exactly the definition of a radius. Therefore, OK is the radius of this quarter circle. So we'll define the radius of this quarter circle as B. So OK equals to B. Actually, OB is also the radius of this quarter circle. Is equal to B units in its length according to our definition. OA is also the radius of this quarter circle. That is equal to B. So we found out that CK equals to A and OK equals to B. What is the length of line segment OC? From the drawing it is very easy to see that OC in total equals to OK minus CK. Again, OK minus CK equals to OC. So I'll write it down. OC equals to OK minus CK. So OC in total equals to OK equals to B. It is the radius of the quarter circle that is equal to B minus CK. CK is A. It is the radius of the small circle that is A. So in total, OC equals to B minus A units in its length. This is line segment OC that is equal to B minus A units in its length. In the next step, I'll copy the right triangle OCQ. This is the right triangle OCQ in the Olympiad. And we will implement the Pythagoras theorem on this right triangle, triangle OCQ. CQ equals to A, it is the radius of the small circle that is equal to A. The hypotenuse OC is B minus A, and OQ equals to 5 units in its length according to what is given as the question. So actually, this is the right triangle OCQ that according to the original drawing. In this right triangle OCQ, according to the Pythagoras theorem, OC squared, that is the square of the hypotenuse, equals to CQ squared plus OQ squared. So I write it down. This will be equation 2. OC squared, that is the square of the hypotenuse, is equal to CQ square plus OQ square. OC, the hypotenuse OC is B minus A, therefore OC square is B minus A square. And it is equal to CQ square. CQ is A, therefore CQ square is A square plus QO square. QO is 5, therefore QO square is 5 squared, that is 25. So in total, according to equation 2, we shall find out that B minus A square equals to A square plus 25. B minus A square is B square plus A square minus 2 times A times B. And it is equal to A square plus 25. So here we have A square on both sides of this equation 2. So A square will get cancelled. After we cancelled A square, in this side of this equation 2, we left only with B square minus 2AB. On the other side of equation 2, we left only with 25. So in total, according to equation 2, we actually found out that b squared minus 2ab equals to 25. In the next step, we do a construction. That is to say, from this point C, we will draw perpendicular on AO. Again, from point C, we will draw perpendicular on AO. So actually, this angle equals to 90 degrees, and this angle also equals to 90 degrees according to our construction. We find the touching point of the perpendicular from point C and AO. This point is point N. By doing this construction, we create the quadrilateral NCQO. Inside this quadrilateral NCQO, we have 1, 2, 3 right angles. The sum of 3 right angles is 270 degrees, so 270 degrees plus the size of this fourth missing angle, in total they must be equal to 360 degrees, according to the rule that states that the sum of the angles in any quadrilateral is equal to 360 degrees. And therefore, this fourth missing angle must be equal to 90 degrees in its size. So inside quadrilateral NCQO, we have 4 right angles, and according to rule 5, any quadrilateral that has 4 right angles must be a rectangle if not a square. So we relate to this quadrilateral NCQO as a rectangle because it has 4 right angles. So write it down. This is quadrilateral NCOQ, that is a rectangle according to rule 5. But we also know that the opposite sides of a rectangle are equal to each other. So in rectangle NCQO, side OQ must be equal to the opposite side NC, but OQ is 5, therefore the opposite side NC must be also equal to 5 units in its length. Likewise, according to the same rule, in the same rectangle NCQO, side CQ must be equal to the opposite side NO, but CQ is 8, therefore the opposite side NO must be also equal to A units in its length. What is the length of this missing isolate AN? From the drawing, it is very easy to see that AN in total equals to AO minus NO. Again, AO minus NO equals to AN. So I write it down. AN equals to AO minus NO. So AN in total equals to AO. AO equals to B, it is the radius of the quarter circle, that is equal to B, minus NO. NO is A, so in total AN equals to B minus A units in its length. AN equals to B minus A. In the next step, I'll copy the right triangle ANC in a new page, and we will implement the Pythagoras theorem on this right triangle ANC. Here by PT is the abbreviation for Pythagoras theorem. Side AN equals to B minus A, NC equals to 5 units in its length, and AC, the opposite AC is the missing side. So actually, this is the right triangle ANC that I copied from the original drawing. This right triangle ANC, AC squared, that is the square of the hypotenuse, equals to AN squared plus NC squared. So I write it down. This will be equation 3. AC squared, that is the square of the hypotenuse, AC squared equals to AN squared plus nc squared. According to equation 1, ac squared equals to x squared plus a squared. Therefore, we substitute ac squared here by x squared plus a squared. Again, ac squared is x squared plus a squared, according to equation 1, and it is equal to an squared. An is b minus a, therefore an squared is b minus a squared plus nc squared. Nc is 5, therefore nc squared is 5 squared, that is 25. So in total, according to equation 3, we can find out that x squared plus a squared equals to b minus a squared plus 25. So x squared plus a squared equals to b minus a squared. B minus a squared equals to b squared plus a squared minus 2 times a times b plus 25. Here we have a squared on both sides of this equation 3. So a squared we get cancelled. After we cancelled a squared, in this side of this equation 3 we left only with x squared. On the other side of this equation 3 we left with b squared minus 2ab plus 25. According to equation 2, b squared minus 2ab equals to 25. Therefore, we substitute b squared minus 2ab here by 25. And we get that x squared in total equals to x squared. And here we have b squared minus 2ab, that is 25 according to equation 2, plus 25. So in total, according to equation 3, we can find out that x squared equals to 25 plus 25, that is 50. So x squared equals to 50. Here we take a root out of this equation and get that x equals to the square root of 50, but 50 is 25 times 2. So we substitute 50 by 25 by 2, 25 times 2, the square root of 25 is 5. So in total this expression equals to 5 times square root of 2. 5 times square root of 2 is 7.071 units. So in total, we found out that the length of this tangent AP is equal to x. It is equal to either 5 times square root of 2 units, or in terms of numbers, the length of this tangent AP is equal to x is equal to 7.071 units in its length. So we finish with the second question. In the next step, I'll summarize the lecture. I'll start with the first question, of course. In the first question, our mission is to find out the length of this tangent AMF that is equal to x. So in the drawing, we have 3 identical circles. This is the long tangent ABC that is tangent to this circle at point A, it is tangent to this middle circle at point B, and it is tangent to this circle at point C. In addition, we know that this is line segment AB, that is equal to 3 units in its length. This is line segment BC, that is also equal to 3 units in its length. In addition, we have, this is the common extent point M. On this common extent point M, we have tangent MD, that is tangent to this circle at point D. The length of this tangent MD is 5 units. We have also tangent ME, that is tangent to this middle circle at this point E. The length of this tangent ME is 7 units. And finally we have also tangent MF, that is tangent to this circle at this point F. The length of this tangent MF is x, and our mission is to find out the length of tangent MF that is equal to x. We have to find out the value of x. So first of all, we define the center of this circle, this point is point P. We define the center of this circle, this point is point Q. And finally, we define the center of this circle, this point is point S. In the next step, we join points P and D together by a straight line. Point P is the center of this circle, point D is the point on the circle itself. Therefore, PD is the radius of this circle. We define the radius of this circle as R. The radius, the radius of those two circles must be also equal to R, because those 3 circles are identical. and because of the fact that the radius PD is equals to R, the radius PD is drawn to point D, that is the point of tendency of tangent MD with this circle, and whenever you have radius that is drawn to the point of tendency, then tangent MD will be perpendicular to the radius DP. If MD is perpendicular to DP, it means that this angle equals to 90 degrees according to rule 1. In the next step, we join points M and P together by straight line. By joining points M and P, we created the right triangle, triangle MPD. So, we implemented the Pythagoras theorem on this right triangle, triangle MPD. According to the Pythagoras theorem, in any right triangle, the square of the hypotenuse equals to the sum of the squares of the perpendiculars. The hypotenuse in this right triangle MPD is MP, therefore the square of the hypotenuse is MP square, and MP square must be equal to PD square plus MD square. So, repeat again. According to the Pythagoras theorem, on this right triangle, triangle MPD, MP square equals to PD square plus MD square. MP is the missing side, so we leave this it is, so it is MP square equals to PD square. PD is R, therefore PD square is R square plus MD square. MD is 5, therefore MD square is 5 square, that is 25. So in total, according to equation 1, we found out that MP square equals to R square plus 25. We repeated on the same process on this middle circle, that is to say we join points Q and E together by straight line. Q is of course the radius of this circle, that is equal to R, and because of the fact that the radius QE is drawn to point E, that is the point of tendency of tangent ME with this circle, and whenever your radius that is drawn to the point of tendency, then tangent ME will be perpendicular to the radius EQ. If M is perpendicular to EQ, it means that this angle equals to 90 degrees, according to rule 1. The next step, we join points M and Q together by straight line. By joining points M and Q, we created the right triangle, triangle MQE. So we implemented the Pythagoras theorem in this right triangle, triangle MQE. According to the Pythagoras theorem in this right triangle MQE, MQ squared, that is the square of the hypotenuse, equals to QE squared plus ME squared. And again, according to the Pythagoras theorem in the right triangle MQE, MQ squared, that is the square of the hypotenuse, equals to QE squared plus ME squared. MQ is the missing side, so we leave it as it is, so it is MQ squared equals to QE square. QE is R, therefore QE square is R square plus ME square. ME is 7, therefore ME square is 7 square, that is 49. So in total, according to equation 2, we actually found out that MQ square equals to R square plus 49. We repeated on the same process on this circle. That is to say, we join points S and F together by straight line. SF is of course the radius of this circle, that is equal to R, and we also join points M and S together by straight line, and we implemented the Pythagoras theorem on this right triangle, triangle MSF. According to the Pythagoras theorem on this right big triangle MSF, MS squared, that is the square of the hypotenuse, equals to SF squared plus FM squared. Repeat again, the right triangle MSF, according to the Pythagoras theorem, MS squared, that is the square of the hypotenuse, equals to SF squared plus MF squared. MS is the missing side, so we leave it as it is, so MS squared equals to SF squared. SF is R, therefore SF squared is R squared, plus MF squared. MF is X, so therefore MF squared is X squared. So in total, according to equation 3, we found out that MS squared equals to R squared plus X squared. In the next step, we join points P and A together by straight line. Point P is the center of this circle, point A is the point of the circle itself, therefore PA is the radius of this circle, that is equal to R. And because of the fact that the radius PA that is equal to R, the radius PA is drawn to point A, that is the point of tendency of tangent ABC with this circle. And whenever you have a radius that is drawn to the point of tendency, then tangent ABC will be perpendicular to the radius AP. If ABC is perpendicular to AP, it means that this angle equals to 90 degrees, and this angle also equals to 90 degrees, according to rule 1. Likewise, we join points Q and B together by straight line. QB is of course the radius of this circle, the radius of this middle circle that is equal to R. And because of the fact that the radius QB that is equal to R, the radius QB is drawn to point B, that is the point of tendency of tangent ABC with this circle. And whenever your radius is drawn to the point of tendency, then tangent ABC will be perpendicular to the radius BQ. If ABC is perpendicular to BQ, it means that this angle equals to 90 degrees, and this angle also equals to 90 degrees according to the same rule, rule 1. And finally, we join points S and C together by straight line. S is of course the radius of this circle, that is R, equals to R, and because of the fact that the radius the radius SC is drawn to point C, that is the point of tendency of tangent ABC with this circle. And whenever you have a radius that is drawn to the point of tendency, then tangent ABC will be perpendicular to the radius CS. If ABC is perpendicular to CS, it means that this angle equals to 90 degrees, and this angle also equals to 90 degrees according to the sum rule, rule 1. So we have here the 3 points P, Q, and S. And because of the fact that those 3 points P, Q, and S are at the same distance from the straight line ABC, therefore those 3 points must be located on one straight line. That is to say, PQS is one straight line. So PQS is a straight line for the same reason that the points P, Q, and S are at the same distance from the straight line ABC. Therefore, the straight line PQS is parallel to the straight line ABC. Okay? And because of the fact that PQS is parallel to ABC, we can implement here rule 17. So I put quickly rule 17. According to rule 17, the sum of one-sided interangles between two parallel lines is equal to 180 degrees. In the drawing we have line A that is parallel to line B. This is the red line C that intersects with those two parallel lines at those 2 points. In addition, we have those 2 angles, alpha and beta. Those 2 angles, alpha and beta, are defined as one-sided interangles. And according to this rule, rule 17, the sum of one-sided interangles is equal to 180 degrees. That is to say, alpha plus beta is equal to 180 degrees. The same thing is true here. Angle 2 and angle 1 are defined as one-sided interangles, and the sum of those 2 angles is equal to 180 degrees. That is to say, angle 2 plus angle 1 equals to 180 degrees. Okay, so we can implement 117 in our drawing. In our drawing, those 2 angles are defined as one-sided interangles, and because of the fact that those 2 one-sided interangles are located between the parallel lines PQS and ABC, the sum of those 2 angles must be equal to 180 degrees. But this angle equals to 90 degrees according to rule 1. So 90 degrees plus this missing angle, in total, the sum of those 2 angles must be equal to 180 degrees. Therefore, this missing angle must be equal to 90 degrees in its size. Likewise, those 2 angles are also defined as one-sided interangles, and because of the fact that they are located between the parallel lines PQS and ABC, the sum of those 2 angles must be equal to 180 degrees according to rule 1. But this angle equals to 90 degrees. So 90 degrees plus this missing angle, in total the sum of those 2 angles must be equal to 180 degrees. Therefore, this missing angle must be equal to 90 degrees in its size. Likewise, those 2 angles are also defined as one-sided interangles. This angle equals to 90 degrees. 90 degrees plus this missing angle, in total the sum of those 2 angles must be equal to 180 degrees. Therefore, this missing angle must be equal to 90 degrees in its size. And finally, those 2 angles are also defined as one-sided interangles. This angle equals to 90 degrees, so 90 degrees plus this missing angle, in total the sum of those 2 angles must be equal to 180 degrees in their sizes, according to rule 17. Therefore, this missing angle must be equal to 90 degrees in its size. So inside this quadrilateral PQBA, we have 4 right angles, and according to rule 5, any quadrilateral that has 4 right angles must be this rectangle in front of square. So we relate to this quadrilateral PQBA as a rectangle because it has 4 right angles. But we also know that the opposite sides of a rectangle are equal to each other. So in rectangle ABQP, side AB must be equal to the opposite side PQ. But AB is 3, therefore PQ must be also equal to 3 units in its length. Likewise, according to the sum rule, in the same rectangle PQBA, side QB must be equal to the opposite side PA. But QB... so actually, we actually found out that PQ equals to 3 units in its length. We know that PQ equals to QB equals to SC, all the area of those circles, that is equal to R. So we actually found out that PQ equals to 3 units in its length. In this quadrilateral QSCB, we have 4 rectangles, and according to rule 5, this quadrilateral is a rectangle. But we also know that the opposite sides of a rectangle are equal to each other. So in rectangle QSCB, side BC must be equal to the opposite side QS. But BC is 3, therefore QS must be also equal to 3 units in its length. In the next step, I copied this big triangle PMS in a new page and analyze this big triangle PMS. This is the big triangle PMS that I copied from the original drawing. This is line segment MQ. The red line is line segment MQ that is defined as a median of this triangle MPS. So what is the definition of a median? A median is a line segment that connects the vertex to the midpoint of the opposite side. This median MQ connects the vertex M to point Q, that is the midpoint of the opposite side PS. Why point Q is the midpoint of PS? Because of the fact that PS in total is 3 plus 3, that is 6, and at the midpoint Q, PS has been bisected into two halves. The first half is PQ, that is 3, and the second half is also 3 units in itself. QS equals to 3. So the median MQ bisects the opposite side PS. But the question is, what is the length of the median MQ? Actually, in this triangle, in any triangle, we have 3 medians. MQ is the median to PS. From this point, we can draw the median to MP, and from this point P, we can draw the median to MS. So in any triangle, we have 3 medians. The median MQ is the median to PS. That is to say, it bisects side PS into two halves. But the question is, what is the length of the median MQ? Actually, we have a special formula for the length of a median in a triangle. This is triangle ABC. Side AB equals to B units in its length. This is side AC, this is equals to C units in its length. This is side BC, this is equals to A units in its length. Here, line segment AD is the median for this triangle ABC. It is the median to side BC, that is to say it bisects side BC. But the question is, what is the length of the median AD? According to the new formula, the length of the median AD equals to the square root of 2b squared plus 2c squared minus a squared divided by 2. Again, the length of the median AD is equals to the square root of 2b squared plus 2c squared minus a squared over 2. So we use this new formula in order to find out the length of this median MQ. According to the new formula, the length of the median MQ will be equal to the square root of 2 times MP squared plus 2 times MS squared minus PS squared divided by 2. Again, MQ equals to the square root of 2 MP squared plus 2 MS squared minus PS squared over 2. So here we multiply this equation with equation 1 by 2. And if we found out that according to equation 1, 2 times MQ equals to the square root of 2 times MP squared plus 2 times MS squared minus PS squared. Here we squared both sides of this equation, equation 1. 2 times MQ squared equals to 2 squared, that is 4, plus MQ squared. So in total, 2 times MQ squared equals to 4 MQ squared. Here the square is the opposite side, is the opposite operation to the root. Therefore, when we square the root, the square cancels the root, and we left only what is inside the root. That is to say, we left, after we squared this side, we left only with 2MP squared plus 2MS squared minus PS squared. Okay, so here we have 4 times MQ squared. But MQ squared is R squared plus 49. Therefore, we substitute MQ squared here by R squared plus 49. And it is equal to 2MP squared. But MP squared, according to equation 1, is R squared plus 25. Therefore, we substitute MP squared here by R squared plus 25. And we have also 2 times MS squared. But MS squared, according to equation 3, is R squared plus X squared. Therefore, we substitute MS squared here by R squared plus X squared, and we have minus PS squared. PS is 3 plus 3, that is 6. Therefore, PS squared is 6 squared, that is 36. Therefore, minus PS squared is minus 36. We open the brackets on both sides of this equation, equation 1, and we shall find out that 4 times R squared equals to 4 times 49, that is 196, so it is plus 196. We have here 2r squared plus 2 times 25, that is 50. So it is plus 50 plus 2r squared plus 2x squared minus 36. Here we subtract 4r squared from this equation, equation 1. So 4r squared here will get cancelled. And 2r squared plus 2r squared is 4r squared. So 4r squared in this side of the equation also will get cancelled. Those two expressions are also get cancelled because they are equal to 4r squared. After we cancelled 4r squared on this side of the equation, we left only with 50 minus 36, that is 14, plus 2x squared. In this side of the equation, we left only with 196. So in total, according to equation 1, we found out that 196 equals to 14 plus 2x squared. Here we subtracted 14 from this equation, equation 1, and found out that 196 minus 14 is 182, so 182 equals to 2x squared. Here we divided this equation, equation 1 by 2, and finally found out that 182 over 2 is 91, so in total x squared equals to 91. Here we took out of this equation and found out that x equals to the square root of 91, but the square root of 91 is 9.54 units. So in total, we actually found out that the length of this tangent, the length of this tangent MF is equals to x. It is equal either to the square root of 91 units, or in terms of numbers, the length of this tangent MF that is equal to x is equal to 9.54 units. So we finished with the first question. In the next step, we presented to the second question. We solve the second question of this lecture. Our mission in this second question is to find out the length of this tangent AP is equals to x. We have to find out the value of x. Actually, tangent AP is tangent to this small circle at point P. Okay, so in the drawing, we have quarter circle AOB. This is quarter circle AOB. Inside this quarter circle, we have this small circle. Tangent OB is tangent to this small circle at this point Q. In addition, we know that the small circle touches the big quarter circle at this point K. Point K is their touching point. In addition, we know that line segment OQ equals to 5 units in Islam. Again, our mission is to find out the length of tangent AP that is equal to x. We have to find out the value of x. So first of all, we define the center of this small circle. This point is point C. And we join point C and Q together by a straight line. Point C is the center of this small circle. Point Q is the point on the circle itself. Is a point on the small circle itself. Therefore, CQ is the radius of this circle. We define the radius of this small circle as A, so CQ equals to A, according to our definition. And because of the fact that the radius CQ that is equal to A, the radius CQ is drawn to point Q, that is the point of tendency of tangent OB with this small circle, and whenever you have a radius that is drawn to the point of tendency, then tangent OB will be perpendicular to the radius QC. If OB is perpendicular to QC, it means that this angle equals to 90 degrees, and this angle also equals to 90 degrees according to rule 1. Likewise, we join point C and P together by a straight line. Point P is the point of tendency of tangent AP with this small circle. Again, we join point C and P together by a straight line. CP is of course the radius of this circle, that is equal to A. And because of the fact that the radius CP is drawn to point P, that is the point of tendency of tangent AP with this small circle, and whenever you have a radius that is drawn to the point of tendency, then tangent AP will be perpendicular to the radius PC. If AP is perpendicular to PC, it means that this angle equals to 90 degrees according to rule 1. In the next step, we join points A and C together by a straight line. By joining points A and C, we created the right triangle, triangle ACP. So we copied the right triangle ACP in a new page and implemented the Pythagoras theorem in this right triangle, triangle ACP. This is the right triangle, triangle ACP. This is a copy from the original drawing. According to the Pythagoras theorem in this right triangle ACP, AC squared, that is the square of the hypotenuse, equals to AP squared plus PC squared. So AC square equals to AP square. AC is the missing side, so we leave this it is. So it is AC square equals to AP square. AP is x, therefore AP square is x square plus PC square. PC is a, therefore PC square is a square. So in total, according to equation 1, we actually found out that AC square equals to x square plus a square. As I mentioned before, point K is the touching point between the small circle and the big quarter circle. That is to say, point K, they have an internal notch between them. That is to say, they touch each other internally at point K. And whenever you have an interval between two circles, you can implement rule 9. Repeat quickly on rule 9. According to rule 9, if two circles touch each other internally, then the straight line that connects their centers together passes for their touching point. In the drawing, we have two circles. The center of this big circle is 0 at point O. The center of this small circle is 0 at point M. And the straight line that connects their centers together is, of course, the straight line OM. And according to this rule 9, the straight line OM must pass through their touching point, that is point P. Again, according to this rule 9, the straight line OM must pass through point P, that is their touching point. Or OMP is one straight line. Again, according to this rule 9, OMP is one straight line. So we can actually implement rule 9 in our drawing. Why? Because now at the moment we have an interval between this small circle and this big quarter circle at point K. The center of this big quarter circle is at point O. The center of this small circle is at point C. And the straight line that connects their centers together is, of course, the straight line OC. So this straight line OC must pass for their touching point, that is point K. Again, the straight line OC must pass for point K, that is their touching point. Or OCK is one straight line. Again, according to rule 9, OCK is one straight line. So we join points O and C together by straight line, and it is very easy to see that indeed the straight line OC passes for point K, that is their touching point, exactly according to rule 9. But what is the length of CK? CK is defined as the radius of this small circle, that is A. So CK equals to A. What is the definition of right element OK? OK is of course the radius of this quarter circle. We define the radius of this quarter circle. OK is B, so OK equals to B. OB is also the radius of this quarter circle, that is B. OA is also the radius of this quarter circle, that is B. So OK equals to B, CK equals to A. What is the length of OC? It is very easy to see from the drawing that OC in total equals to OK minus CK. Repeat again, OC equals to OK minus CK. So OC equals to OK, that is B, minus CK, that is A. So in total, OC equals to B minus A units in its length. In the next step, I copied the right triangle OCQ in a new page and implemented the Pythagoras theorem on this right triangle OCQ. So actually, this is the right triangle OCQ that I copied from the original drawing. In this right triangle OCQ, OC squared, that is the square of the hypotenuse, equals to CQ squared plus QO squared. OC is B minus A, therefore OC squared is B minus A squared, and it is equal to CQ squared. CQ is A, therefore CQ squared is A squared, plus QO squared. QO is 5, therefore QO squared is 5 squared, that is 25. So in total, according to equation 2, we should find out that B minus A squared equals to A squared plus 25. B minus A squared equals to B squared plus A squared minus 2 times AB, and it is equal to A squared plus 25. Here we have A squared, both sides of this equation, equation 2, so A squared will cancel, and after cancel A squared, in this side of equation 2, we have to leave with B squared minus AB. In the other side of this equation 2, we have to leave with 25. So in total, according to equation 2, we found out that B squared minus 2AB equals to 25. In the next step, we did the construction, that is to say, from point C, we drew perpendicular on AO. Again, from point C, we drew perpendicular on AO. So actually, this angle equals to 90 degrees, and this angle also equals to 90 degrees according to our construction. We define the touching point of the perpendicular for point C and AO. This point is point N. By doing this construction, we created the quadrilateral NCQO. Inside this quadrilateral NCQO, we have 1, 2, 3 right angles. The sum of 3 right angles is 270 degrees, so 270 degrees plus the size of this 4 facing angle, in total it must be equal to 360 degrees, according to the rule that states that the sum of the angles in any quadrilateral is equal to 360 degrees. Therefore, this 4 facing angle must be equal to 90 degrees in its size. So, inside this quadrilateral NCQO, we have 4 right angles. And according to rule 5, any quadrilateral that has 4 right angles must be at its right angle front square. So we add to this quadrilateral NCQO as a right angle because it has 4 right angles. But we also know that the opposite sides of a right angle are equal to each other. So an right angle NCQO, side OQ must be equal to the opposite side NC. But OQ is 5, therefore NC must be also equal to 5 units in its length. Likewise, according to the same rule, in the side right angle NCQO, side CQ must be also must be equal to the opposite side NO. But CQ equals to A, therefore the opposite side NO must be also equal to A. What is the length of the missing line segment AN? AN equals to AO minus NO. Again, AN equals to AO minus NO. AN equals to AO, that is B. This is the radius of the quarter circle, that is B, minus NO. NO is A. So in total, AN equals to B minus A units in its length. In the next step, I copy the right triangle OCQ on a new page and implemented the Pythagoras theorem on this right triangle OCQ. So, according to the Pythagoras theorem, in this right triangle OCQ, OC square equals to CQ square minus QO square. OC is B minus A, therefore OC square is B minus A square, and is equals to CQ square. CQ is A, therefore CQ square is A square, plus OQ square. OQ is 5, therefore OQ square is 5 square, that is 25. Here we open the brackets and found out that B minus A square equals to B square plus A square minus 2 times AB, and is equals to A square plus 25. Here we have A square on both sides of the equation, so A square will get cancelled. And we have to only with B square minus 2AB equals to 25. So according to equation 2, B square minus 2AB equals to 25. So in the next step, I copy the right triangle A and C in a new page, and we implemented the Pythagoras theorem on this right triangle A and C. So this is the right triangle A and C that I copied from the original domain. We have already found out that AM equals to B minus A units in its length, and C equals to 5 units, and AC is the missing side. The opponent AC is the missing side. So according to the Pythagoras theorem, in this right triangle A and C, AC squared, that is the square of the hypotenuse, equals to AN square plus NC square. Repeat again, AC square equals to AN square plus NC square. AC is the missing side, so AC square equals to, actually according to equation 1, we know that AC square equals to X square plus A square. So AC square equals to X square plus A square, and it is equal to AN square. AN is B minus A, therefore AN square is B minus A square plus NC square. NC is 5, therefore NC square is 5 square, that is 25. So in total, according to equation 3, I actually found out that X square plus A square equals to B minus A square plus 25. So X square plus A square equals to B minus A square. B minus A square equals to B square plus A square minus 2 times AB plus 25. Here we have A square on both sides of the equation, so A square will get cancelled. After we cancel A square, on this side of this equation 3, we left only with X square, and the other side of this equation 3, we left with B square minus 2AB plus 25. But according to equation 2, B square minus 2AB equals to 25. So we substitute B square minus 2AB here by 25, so in total we actually found out that according to equation 3, X square equals to B square minus 2AB is 25 plus 25. So X square equals to 25 plus 25, that is 50. X square equals to 50. Here we took out all of this equation and found out that X equals to the square root of 50. 50 is 25 times 2, and the square root of 25 is 5. So in total, this expression equals to 5 times square root of 2. 5 times square root of 2 is 7.071 units. So in conclusion, we found out the length of this tangent AP that is equal to X. It is equal to either 5 times square root of 2 units, or in terms of numbers, the length of this tangent AP that is equal to X is equal to 7.071 units in its length. Okay, thank you very much.